Hi friends, welcome to Unacademy. Myself Bhavani. Students, as you all know, Unacademy offers plus courses for Karnataka CET students. What is a plus course? A plus course is a structured live course where you will have both class 11 and class 12 topics will be done in detail. Whenever you have doubts, there is also live doubt clearing session wherein you can clarify your doubts. At regular intervals, we have quizzes student. Quizzes are specially for self-analysis. There is a comprehensive batch which has already begun, so you can enroll your name. Apart from that, there is also daily practice paper, full-length mock test with analysis. And all these are for single subscription, you are getting unlimited access. So in order to get a 10% discount, kindly make use of the code Bhavani Live. So you are supposed to subscribe the YouTube channel student. See to it that you are subscribing the YouTube channel, and also you are going to the description. Check the description box there. You will find all my special classes and plus classes. Students, special classes are the free classes. So you can go through and you can watch those videos which are already previously done and which I will be conducting in future. So kindly see to it that you are checking the description box where you will find all the special classes and also the plus classes. Kindly press the bell icon so that you get enough notifications. And whenever you are liking my class, kindly press the like button and share, and also you see to it that you are subscribing. There is also a champions batch which will be which has started from 14th of October. Okay, so you can enroll your name here. So kindly make use of the code Bhavani Live to get 10% discount. There is a comprehensive batch and also you have a Kannada batch. The Kannada batch also has started. This is a Kannada batch student. So there is a 12 months plan at the rate of 12,375, and we also have a 6-month plan at the rate of 10,125. So students, kindly make a note that you are using the code Bhavani Live for any of the subscription, and make use of get those the discount, whatever 10% discount you are supposed to get. So do not forget to subscribe the YouTube channel. Okay, see to it that you are using the description box and you are watching all my special class and plus class also. See to it that students, whenever you watch the class, whenever you are liking my video, do not forget to press the like button and always share these videos among your friends. So students, today I'll be dealing with structure of atom. So today we are going to discuss few questions based on structure of atom. Okay, so let us begin with one by one. I hope you are ready, students. Students, you are already ready. That's what I feel, isn't it? So everyone is ready, right? Okay. So we will start with question number 1. You can see structure of atom, students, is one such chapter actually which you can attempt easily. You will not face that difficult question here. Most of the questions will be easier and you can actually solve it without much difficulty. Okay, so students, you can actually whenever you get Whenever you get answer, try to find out, try to find out the answer and also put it in the comment box. Okay, students, so we will start with question number 1. Question number 1, the total number of orbitals associated with principal quantum number 5 is option A 5, option B 20, option C 25 and option D is 10. So how many orbitals are possible for principal quantum number 5? Students, do you have the answer? Okay, I can see some of you are giving the answer. Okay, that's really nice. Students, try to find out the answer. Okay. Okay. Most of them are giving the answer as, I think it is, some of you are giving as answer as A also. Alright. See student, you know what is principal quantum number. If the principal quantum number is n, remember this formula student, for number of orbitals, n square is the formula. If number of orbitals are asked, so you needn't struggle, you can make use of the formula n square. So n square is equal to, what is the principal quantum number? 5. So 5 square, that is equal to 25. So how many orbitals are possible student? Answer is option C. That is 25. Now student, in case if you have forgotten this formula, then also we can solve. See, when I say n is equal to 5, L is equal to 0, 1, 2, 3, 4. That means I have 5s, because this combination will give you 5s. I will get 5p. Yes, Roshan, you are giving the right answer. Yes, I have observed it. You have given the right answer. So 5s, 5p, 5d, 5f, 5g. This is another way of solving it. I am just giving you different methods. Okay. 5s means 1. P means px, py, pz. So there are 3. D means 5. F means 7. G means 9. So 9, you add all these, how much you are getting? Are you getting 25 student? Just see. So answer is option C, 25. Have you understood now? I told you simple question. See, asked in JEE Main, I found it, a easy question. So we can actually even, expect in CET exams also, though it is asked in JEE Main. Okay. We'll go to the next question. Which of the following is the energy of a possible excited state of hydrogen? Okay, read the question now. Which of the following is the energy of a possible excited state of a hydrogen? But the value is given in electron volt. I am very sure if you are not learning in chemistry, I am very sure that you are learning in, even in physics you learn this chapter. So you know the formula in terms of electron volt. Okay, I am getting the answer as B. Okay, Vidya is answering B. Roshan is answering B. Okay, let me see whether it is B. What is the formula student? En is equal to minus 13.6 into Z square by N square. Isn't it? Z square by N square electron volt. Minus 13.6 for hydrogen. What is Z student? Z is atomic number and for hydrogen it is 1 divided by N square. Excited state of hydrogen. That means N will be student 2, isn't it? So 2 square. So minus 13.6 divided by 4 and you are getting the answer as minus 3.4 electron volt. Very good student. The answer is option B, minus 3.4 electron volt. Okay. Alright, you see, or asked in JEE exams, but the questions are easy. That's why I told you we can think of such question even in CET, or it can be in COMET exam, or related NEET exam, etc. Okay, we'll read the question now. Question number 3. Mangalore. I'm from Mangalore, student. My name is Bhavani and I'm from Mangalore. Okay. The de Broglie wavelength of a particle of mass 6.63 gram moving with a velocity of 100 meter per second is option A 10 to the power of minus 33 meter, option B 10 to the power of minus 35 meter, option C 10 to the power of minus 31 meter, and option D is 10 to the power of minus 25 meter. So we need to try with this question. Look here, student. Mass is given, velocity is given, and the de Broglie wavelength is asked. So de Broglie equation, isn't it? What is the de Broglie equation? You will be solving. I am also solving the problem, student, but I expect that you solve quicker than me and you will get the answer. Okay. So lambda is equal to h by, you are really solving quickly. Quickly means you are solving really fast. Okay, I am having an answer anyway. So h is lambda is equal to h by mv, student. So you know what is h. H is Planck's constant, 6.63 into 10 to the power of minus 34 divided by mass. Mass is how much? 6.63 gram is given. So in kg, 10 to the power of minus 3 into v, velocity is given as 100 meter per second, isn't it? So how much do we get? What is the answer we are getting? So this is going to be cancelled here. So you are going to get 10 to the power of minus 31, isn't it? 10 to the power of minus 31 and 10 to the power of minus 2. That means you are going to get 10 to the power of minus 33 meter. Therefore, answer is option A, student. Okay. All those students who have actually got answer A is exactly the right answer. Very good, students. Good going. Okay. I hope, is there anyone who is from class 11 who has joined, presently in class 11 and joined? Okay. So we will go to question number okay. We will go to question number 4. Okay. Roshan, you are in class 11. Okay. That means just now all these chapters are done. I hope these chapters are done for the time, I hope it is completed. Anyway, we will go to question number, 4. The correct set of 4 quantum numbers for the valence electron of rubidium atom is. So you have to write the quantum number for the valence electron of rubidium. Valence electrons of rubidium, student. 4 options are given. So kindly go through the option and you write the answer. Okay, I am waiting for your answer. Then only I will try to find out the answer, because it's always nice when students give the answer. Okay, as you can see, student, it is asked a question from the previous exam, JEE Main 2014. It is asked. Okay, so just find out. So just try to find out. I am just giving you a second. Anyone? I am expecting answer from your side, student. Rubidium atom, valence electron is asked and the quantum number should be assigned for that valence electron. Okay, so how do you find out? Okay, I will start. As you are thinking, let me start. Rubidium, see, there are different ways in which you can solve the problem actually. One of the way is to write the electronic configuration. Now when I say electronic configuration, we are not going to write everything. So we are going to mention krypton here. The nearest noble gas, that is krypton. So krypton is 36. Now you know helium, neon, argon, krypton, isn't it? So this is 1s2. So this is 2, this is 3, this is 4, isn't it? So it is, you are getting it as krypton is 36. Okay. So what will be the next orbital? Helium, neon, argon, krypton. So what will be the next orbital there? How much it is? 5s1. Rubidium is so this is 2, this is 3, this is 4, this is fifth one. The orbital filled are 5s2, 5p6 student. So I am already written here. Okay, the orbitals which will be filled here. Therefore, this will be 37 means 5s1. Okay, krypton 36 and 5s1. I hope I am making it clear. I hope you are understanding. Okay, so 36 and 1, 37. Now how many valence electron we have? There is only one valence electron. So we will write n value for this one. Look here student, this is 5s1. So what is the n value? N value is 5. What is the L value? L value is SS, means what is the L value? It is 0. When L is equal to 0, what is the M value? M is equal to 0. There is only one electron, that means the S is plus half. That is spin quantum number is plus half. Therefore answer is 50012. And you know what are the different ways in which you can solve? See, we know lithium, sodium, potassium, rubidium, isn't it? So you are getting here rubidium. So this will be 1s2, 2s1, isn't it? So this will be 3s1, outermost shell. Potassium is 4s1. Rubidium is 5s1. Students, I hope it is clear. Directly you can find out the outermost shell is 5s1. So this will be the quantum number. Have you understood, student? Are you getting it? Since there is only one electron, only one spin quantum number, that is plus half, is assigned. Okay. Now look at the question now. Simple question but asked in the NEET exam. Two orbital occupying the same orbital. Okay, it should be two electron. Two electron occupying the same orbital are distinguished by spin quantum number, principal quantum number, magnetic quantum number, azimuthal quantum number. So you have two electrons occupying the same orbital. How do you distinguish it? With which quantum number? Students, your answer. What is the answer, student? Suppose if you think, student, maybe 4s has 2 electrons. So let me call one as electron 1 and the other electron as electron 2. Now you know N, L, M, S value will write. Principal quantum number N is 4 for both the electron. You cannot find out. The azimuthal quantum number, you can see the azimuthal quantum number, if N is equal to 4, okay, What will be the azimuthal quantum number? Since S is equal to, it's given 4s, L is equal to 0. When L is equal to 0, you know M is also equal to 0. But spin will be plus half for one electron and minus half for other electron, isn't it? One will be in clockwise and the other one will be in anti-clockwise. So you can see here it is the only spin quantum number which is different for two electrons occupying the same orbital. So answer is spin quantum number. Very good, student. Okay, spin quantum number. Okay, go to this question now. Which of the following pairs of d orbital will have electron density along the axis? You have 5 d orbital, out of which where do you find the electron densities along the axis? 4 options are given. So you can tell me what is your right answer. You can write it in the comment box, student. So which is your right answer? Electron density is along the axis. If I am writing this as XYZ, if I take dz square, I get electron density is concentrated over z direction, z axis. If I take maybe x, y, z, and if I take dx square minus y square, it is oriented along, you will get a, you have drawn a diagram like this. That means it is oriented along the axis x and y. If you take dxyz, okay, dxy, it is in between x and y. If you are drawing the diagram, electron density, you are getting like this. It is in between xy plane. It is not along x and y axis. If I am going to write dxz, it is in between xz. In between xz. If I am taking maybe dyz, dxyz, if it is yz, then it is in between yz plane. Student, it is only in dz square and dx square minus y square. The electron density is mostly along the axis. See, because the density is here, you are getting this kind of a shape. So answer should be dz square and dx square minus y square. Option A. I hope it is clear. Option A. In all these 3 cases, they are not along the axis. They are in between the axis. Okay. Now look at the question. If the radius of the first orbit is A0, the radius of the third orbit is it 3A0, 6A0, 9A0 or 1 by 9A0? If the radius of the first orbit is A0, the radius of the third Bohr orbit is. So you can tell me the answer. Students, you can give the answer. Some of you are giving the right answer. Very good. So what will be the answer? What is the formula, student, for radius? For radius, Rn is equal to A0 into n square. N is the orbit, isn't it? So when I say third orbit, n is equal to 3 square into A0, that is nothing but 9A0. Therefore, answer is option C, 9A0. Have you understood? Is it clear? Simple question, but asked previously, student. Okay. We'll go to the next one. radial nodes present in 3s and 3p orbitals are? Radial nodes present in 3s and 3p orbitals are. So you have to find out how many radial nodes are there in 3s and how many are there in 3p. Okay, so you can find out the answer. Students, you remember my next YouTube session will be on 17th. That is, not tomorrow, day after tomorrow, exactly at 2 o'clock. So see to it that you are joining the classes exactly at 2 o'clock. And also, as I told you, kindly see the description box, student. If you see the description box, it will be very clear. All my special classes, all my plus classes, you will come to know. So you can attend those classes. There are free special classes that also you can attend. Okay, students? Okay. So how do we solve radial nodes? Whenever the question is a radial node, you use the formula. Okay. Concept wise also we know. Otherwise, use the formula radial node is equal to n minus L minus 1. Okay, n minus L minus 1. When I say 3s, if I say 3s, n is equal to 3 minus L is equal to S means 0. Students, you know, L is equal to 0 means S, L is equal to 1 means P, L is equal to 2 means D, isn't it? So this is 0 minus 1. So 3 minus 1, you are getting 2. Whereas in case of 3P student, 3 minus, what is the L value? 1 minus 1. So 3 minus 2, that is 1. So answer is 2 and 1, option C. Is it clear? Understood, students? Okay. Now, if at all the question is angular node, then you should remember, just for your reference, I am writing here, if angular nodes are asked, then it is equal to L. Okay. So, for p orbital, 1 it is angular node. For d orbital it is 2. Okay. So angular node is nothing but it is equal to L. Okay. Look at the question now. Read the question. The relationship between energy E1 of the radiation with wavelength 8000 angstrom and the energy E2 of the radiation with wavelength 16,000 angstrom. So what is the relation? Find out, students. We know that E1 is equal to h nu. H nu can be written as hc by lambda. Similarly, E2 is equal to hc by lambda 2. Correct? Because nu is equal to c by lambda. You can see this gets cancelled. So I can write E1 by E2, that is equal to lambda 2 by lambda 1. You know the lambda 2 value, how much it is given? 16,000, and lambda 1 is given as 8,000. Correct, student? Okay, so you are going to get 2. So E1 is equal to 2E2. So students, you see what is the answer you are getting? E1 is equal to 2E2. So this will be the right answer. I hope you have understood, student. Isn't it? Okay, so we will go to one more question. Impossible orbital among the following is? Very simple question asked in the exam. I am expecting answer from your side, student. Impossible orbital among the following is 2s, 3f, 2p and 4d. So which is an impossible orbital? Which is impossible orbital? Come on student, I'm expecting answer from your side because it's a simple question. It's not possible at all. Which orbital I have written as impossible there? Any answer from your side? Is it 2s? Is it 3f? Is it 2p? Or is it 4d? So which is your answer? What is the right answer? See, we have written 3f. When I say 3f student, you know n is equal to 3. N is equal to 3 means L can have values 0, 1, 2. So you have 3s, you have 3p and you have 3d. So when n value is 3, there is no 3f. There is no 3f possible at all. When n is equal to 3, it can be 3s, 3p, 3d, at the most not more than that. That means 3f is an impossible orbital. Are you getting it students? So students, this session will be only for half an hour session. So I am actually ending my session. We have crossed the time. So my next class will be exactly at 2 o'clock, that is on 17th student. Kindly attend that class also and see to it that you are getting maximum benefit. If you are liking my class, in case if you are liking my class, do not forget to press the like button and always see to it that you are sharing these videos among your friends. Okay, always share valuable comments whenever you like the class. So bye students, take care and see to it that you are preparing for competitive level exam from now itself. Class 11 or class 12, you have to start preparing for competitive level exam from now. So by this, bye bye students, take care. So see you on 17th exactly at 2 o'clock. Bye students.